All right, today we are continuing the discussion with factoring and we are talking about special cases. So this is section 3.3. There are actually three different quizzes in 3.3. So I've separated them. Here you can see difference of squares is one. So everything in example one covers one quiz. Perfect square trinomials are going to be example 2 and example 3. That's another quiz. And then the sum or difference of two cubes, which is example 4, will be the last one. So if you go through this entire video, you practice, you feel like you know what you're doing on these, you should be ready for all three of those. So when we are talking about our first special case, a difference of squares, what I've written up here are the things that have to be true in order for it to be that type of factoring. So first of all, it has to have only two terms. Remember that terms are what's separated by addition or subtraction. So that means that all difference of squares are binomials. Two terms. A second thing that has to be true is that all the variables you see in the expression have to have even powers. So pretty much all of the ones you're going to see in this particular quiz are squared. But just so you know, they could be x, y, a, b, whatever your variable is, to the fourth power, to the sixth power. Anything that's even that meets all of these qualifications could potentially become a difference of squares. So they are binomials. The variables have even powers. The coefficients have to be perfect squares. That means both of them, both coefficients. Since you have two terms, we should have two coefficients. Now, sometimes one of the coefficients is a 1, so it seems like there isn't one. Within those perfect square coefficients, one of them has to be positive and one of them has to be negative. Typically, when we write these, the first one is positive and the second one is negative. It doesn't have to be written that way, but that's typically how we're going to see it. So this is why it's called a difference of two squares, because the negative coefficient makes that subtraction. The squares is because even powers have perfect square roots. And so that holds all of our qualifications. Some of what you're going to be asked to do to show mastery is to be able to identify these properties, to know what has to be true. So for example 1, we're going to factor it. We're going to go through our checklist. So yes, it's a binomial, one term, two term. Number 2, the variables have even powers. This is my only variable. Power is 2, so we're good to go on that. Number 3, both coefficients perfect squares. So the coefficient in front of this x squared is a 1. 1 is a perfect square, so we're okay. And then 169. Now, if you don't know if something is a perfect square or not, then what you need to do is check it on the calculator. If you just know, then that's great. And you're going to start hopefully recognizing some of these because you're going to see the same perfect square numbers over and over and over again. But if you're not sure, you can check it. Don't put the negative sign in with it because we can't have square roots of negative numbers. Those are imaginary. So type your number, in this case 169, press enter. If it comes out as a whole number, then it is indeed a perfect square, and what you see is the square root. So this is a difference of two squares. So when I go to factor them, the format for factoring a difference of squares is always going to be square root of whatever the first term is plus square root of whatever the second term is, and then a second parenthesis with the exact same thing except a minus sign. Now, it doesn't really matter which parenthesis has the plus and which one has the minus, as long as it's one of each. So the square root of 1x squared is just x. So square root of the first, x. So that means in the fronts, I put x. I know that one of my parentheses is going to be a plus and one's going to be a minus. That's always true with these. And then we saw in our calculator that the square root of 169 is 13. So plus 13 here, minus 13 there. Remember, as I've said before, any type of factoring, if I FOIL this back out, I should get my original. And so if you don't, then you need to go back and see where you might have made a mistake. So this is our answer right here. Now let's look at B. So we go through the checklist. Does it have two terms? 81a squared is a term. 100 b squared c squared is a term. So yes, binomial. Do I have even powers? Squared, squared, squared? Yep. Do my coefficients have perfect squares? So square root of 81, I think most of you know that that one is 9. So 9a would be the square root here. Then 100 is also a perfect square. Its square root is 10. Of course, the square root of b squared is b, square root of c squared is c. So yes. Is one of the coefficients positive and one negative? 81 is positive, 100 is negative. So yes, we've met all the qualifications. Notice that I've already really written down the square roots here, which means I just need to fill it into my format. Square root of that first term goes in the fronts. Plus here, minus here. Square root of the back term, second term in the back, so 10bc. So notice here that at the end I happen to have two variables. That's fine. This one I had no variables. Sometimes in the back you only have one. It doesn't matter how many variables there are as long as all of these qualifications are met. And so that is my answer for that. So that prepares you for the difference of squares. Now we're going to go on and look at the perfect square trinomials, which we often nickname as PSTs. So in order to be a PST, the first and third terms have to be perfect squares. Now, notice it says first and third in the name here. We don't have it in the checklist because it's in the name. In order to be a PST, it has to be a trinomial. So three terms, first and third have to be perfect squares. The coefficients of both perfect squares have to be positive. So that means that my first and third terms are positive. So that's saying the same thing. The middle term has to take the form 2ab or negative 2ab. What that means is that it's double, because that's what multiplying by 2 does, double the product of the square roots of the first and third terms. So in this particular quiz, you're going to see some like example 2. I didn't want you to get thrown off by the weird question marks. So here, they're trying to get you to come up with the numbers and or letters that are going to make the polynomial a perfect square trinomial when you put it in place of the question mark. So this is just testing, can you make it meet these qualifications in my 1, 2, 3 list? So for A, x squared plus 28x plus something. I have to find that something. Now remember, I know that this middle term has to be in the form 2ab because this is a plus. The square root of my first term is x. So I know that 28x has to equal 2 times the square root of the first term, which is x, times the square root of whatever the question mark is. So that helps me find what goes here. Now, you don't have to write out complicated equations like this, because if your question mark's at the end, it's going to be the same process every time. If I divide both sides by 2, this becomes a 14. If I divide away the x, these go away. So 14 has to be equal to the square root of whatever I need. So all you really have to do is divide the middle term by 2. So divide middle by 2 and then square it. So 28 divided by 2 is 14, and then I square 14. If you don't know what that is, again, feel free to use a calculator. We get 196. So that means that if my question mark were 196, that would become a perfect square trinomial. Now, if the question mark's in the middle, we have to use a little bit different process because now I'm trying to find that 2ab. So a is going to be the square root of the front. So the square root of 81 is 9. Square root of x squared is x. The square root of the back term, 121, is 11. So I know that my question mark, which is going to be 2ab, is going to be 2 times, the a would be square root of the first term, so 9x, times b is the square root of the third term, which is 11. So I have 2 times 9x times 11. So 2 times 9 we know is 18, and then 18 times 11 gives us 198. So you don't need the x because the x is already written. So just 198 would be my answer there. So when you've got the weird question marks, these are the process. You look to see whether it's going to be the question mark on the end or in the middle. If it's at the end, divide by 2 on the middle coefficient and square it. If it's a question mark in the middle, you're going to take the square roots of the ends, multiply and double. All right, example 3. Now we're actually finding the correct factorization for a perfect square trinomial. So when I look at this one, if it meets the qualifications, we'll see how these look when they're factored. So first and third terms, both perfect squares. 16x squared, yes. 49, yes. Again, if you're not sure, check in the calculator. So the square root of 4x, or 16x squared is 4x. I usually write them underneath. Square root of 49 is 7. So now I just need to make sure that 56 is 2 times 4 times 7. So again, check it to be sure. So 2 times 4 times 7 is 56. So I know, yes, this is a PST. So the format of factoring a PST starts out kind of similar to the difference of squares in that we put the square root of the front in the front, the square root of the back in the back, but this time the sign is based upon the middle. So if the middle is a plus, they're both a plus. If the middle were a minus, they're both going to be a minus. Now, some of the times on your quizzes, they'll write it exactly like this. Technically, however, this isn't simplest form because these are the same binomial. So when we have two things multiplied that are the same, that really means that it's squared. When we have 5 times 5, that's the same thing as 5 squared. So 4x plus 7 times 4x plus 7 is 4x plus 7 squared. So sometimes they'll give you a choice of the answer that looks like the top. Sometimes it'll look like this on the bottom. All right, let's look at the next one. So I've got 4x squared minus 20xy plus 25y squared. So first and third terms are both perfect squares. Square root here would be 2x. Square root here would be 5y. So yes to that one. Coefficients of both perfect squares are positive. Positive 25, positive 4. Yes. Check the middle term. So when I multiply 2x times 5y, I get 10xy. If I double it, I do indeed get 20xy. So yes, this is a winner. So fill it in. Square root of the front, go in the front. Square root of the back, go in the back. This time my middle term has a minus, so these are both minus. And again, sometimes that'll be the final answer. Other times it won't be, and it'll be written 2x minus 5y squared. All right, so that covers what you need for the perfect square trinomials quiz. Final special case are the sum or difference of two cubes. And I just want to give you kind of a heads up on this, that on some of the questions on the last quiz, some of them are not a sum or difference of two cubes. They throw in there some PSTs as well as some of the difference of squares. So just make sure you're not assuming that everything in that last quiz is a sum or difference of two cubes. So in order to be a sum or difference, notice that it can be either, so a plus or a minus is not important. It has to be two terms, so that means it's a binomial. All of the variable powers have to be multiples of 3. You're mostly just going to see 3's, but it could be 3, 6, 9, 12. Any multiples of 3 could possibly fit into the pattern for sum or difference of two cubes. The coefficients themselves have to be perfect cubes. So many people do not know their perfect cubes as well as they know their perfect squares. So I want to make sure that you know how to find a cube root on a graphing calculator. I'm going to show you two different ways because I'm not sure on the scientific calculators how it's written, or like on an online one. So on this calculator, the cube root is in the math button. So hit math and you can see there it's choice 4. So if I hit 4, it'll do cube root for me. So that's one way I can do it. So if I want to check this first number here, 64, to see if it's a perfect cube, I can type in 64, press enter. Yep, now I can see it. Now, the other way that you can do it, or may have to do it if you have a different calculator, is looking for something that looks like this, like what you see in number 5, where it has x root. So if you don't see anything on the calculator that has a cube root, then you're going to look for the x root. And if you're doing an x root, that means that you're going to press either just x root by itself and type in the 3. While I'm at this, I'm going to do the next number, so 343 right here. And press enter. On some calculators, when you find the x root button, it doesn't have like that little fill-in block. So on some of them, you have to press the 3 first and then choose an x root. Now I can't show you that on, oh, it did work. I didn't think that would work since this one had the other option. But sometimes you have to press the 3 first before you press the x root button. So I'm going to check the third number we've got here, so that way we've got a lot of our checking for perfect cubes out of the way. All right, so we've checked 3 of these numbers and all gotten them to come out as whole numbers, which means they are perfect cubes. If they don't, then that means it can't be a sum or difference of cubes. And if it doesn't factor another way, so let's say that you had, I don't know, x cubed minus 17. Well, 17 is not a perfect cube. X cubed is, but this is not. And it's not a perfect square either, and it doesn't factor via any of the other methods that we've used. So what they call these is irreducible. So you will have some in the quiz that are not factorable, and that's what they call them, irreducible. Okay, so I'm going through now with my checklist for this first example. It is two terms, it's a binomial. Variable powers are multiples of 3. I already checked both coefficients, they are perfect cubes. So we saw in the calculator that the cube root of 64 was 4. Cube root of x cubed is just x. And we saw that the cube root of 343 right here is 7. So when I factor a sum or difference of cubes, it's a little more complicated than the PSTs or sum and difference of squares. The first thing that I do is create what I call the little parenthesis and a big parenthesis. So you're going to write one that's binomial size and one that's trinomial size. So the baby and the mama. So in your little parenthesis, it gets the cube roots. So the 4x and the 7, and it gets the sign between. So in this case, the sign was a minus. If it had been a plus, we would put a plus here. Now, the big parenthesis takes the pattern or form where you square, because you're going to get 3 terms, it's trinomial. You take the little parentheses first term and you square it. In the back, you're going to take the little parentheses second term and square it. Okay, so let's do that. If I take 4x and I square it, 4 squared is 16, x squared is x squared. In the back, the second term is a 7. When I square it, that gives me 49. In the middle, you are going to multiply the big parentheses first and third. So I'm going to take, or not the big parentheses, sorry, why did I say big? That should be little. So multiply 4x times 7, which is 28x. Now, it's important that you know what signs go in here. We use the acronym SOAP to help us remember. SOAP stands for same. So this sign is the same as the original. My next sign should be opposite. So the original was a minus. Opposite of that is plus. And then AP is always positive. So plus. So this would be my factorization. All right, now I'm going to go through that one more time because I know it's confusing in comparison to the other two. Just takes a little bit longer to understand. So if you need extra help, please reach out. So I check my checklist. 2 terms. Yep, it's a binomial. Variable powers are multiples of 3. P cubed, Q cubed. Yes. Coefficients are perfect cubes. Well, I already checked the 27 earlier. So cube root of 27, yes, gives me 3. Now I need to check the 125. So math, cube root, 125. And yep, cube root is 5. So this would be 3p for the cube root. This cube root would be 5q. So I set up my little parenthesis, so my baby and my mama. Binomial size, trinomial size. So in the little parenthesis, I get the cube root and the sign between. So 3p, sign between is plus, 5q here. Now, big parenthesis, take the little guy, square the front. So 3 squared is 9, p squared is p squared. In the back, I'm going to take 5q and square it, which gives me 25q squared. Now the middle multiplies. So I'm going to multiply 3p times 5q, which gives me 15pq. Then I use my soap. You always want to use soap to keep yourself clean. So same plus opposite minus always positive. And now I've got my baby and my mama parenthesis complete, and so that's fully factored. All right, again, practice, practice, practice. That's the best way to become good at factoring. And like I said earlier, factoring does not go away. You're still going to be seeing this even in the last couple units. So make sure you reach out if you need some help.